Hello, today we will use a real-world example and apply some hypothesis testing. I will be using energy consumption levels of gas, electric, and solar heating systems, and we'll answer a few questions. One will answer, do different heating systems have significantly different mean energy consumption? We'll also answer, does switching from gas to solar heating result in a significant reduction in energy consumption? And lastly, we'll answer, do the variances of energy consumption differ significantly between the three heating systems? This was not data that was actually taken from homes. I generated this data using Python, as you can see. So the first thing we'll do is check for normality. One of the assumptions that's commonly made in hypothesis testing is normal distribution. So we'll test normality using the Shapiro-Wilk test. And I have the tool set that if the p-value is less than the significance level, then it will give us a warning that the data may not be normally distributed. So we'll run the test and see what happens. Both gas and solar consumption, they're all greater than 0.05. So we have a normally distributed data set. Next, we'll check for homoscedasticity or equivariances. That's another common assumption. So we use the Levine test to test for equivariances. Here we see that the p-value is less than 0.05. So we must reject the null hypothesis that the variances are equal. They are actually shown to be significantly different across the heating system. And that matters because that will affect the type of test, hypothesis test that we run next. So for example, we're running a Wilcoxon matched pairs test. The alternative of that is the paired t-test, but we use that when we have equal variances and normally distributed data. But because we see that our variances are not equal, we will use the Wilcoxon matched test. And so we'll be testing pre and post. So this will be testing whether if someone changes from gas to solar, so gas will be pre, solar will be post. If they changes from gas to solar, is there a significant difference in the median consumption? As we run it, the p-value is 0.5, so it is significantly higher than the p-value, and we must fail to reject the null hypothesis, showing that there is no significant difference before and after in the median consumption of gas and solar energy. Next, we'll look at comparing the means. And again, we use the Welch's t-test rather than just a regular t-test because the variances are unequal. So the first two that we will compare is gas versus electric. And then the next one that we'll compare is gas versus solar. As you can see, we have the variances, equal variances is false because again, we have unequal variances. So as we test the comparison of mean of gas and electric, we get a p-value of 0.09, which is higher than the p-value or our significance level. So we must fail to reject the null hypothesis. And then we compare gas to solar energy. And our p-value is 0.004, which is less than our significance level. So we must reject the null hypothesis. And this shows that the mean of gas and solar heating has significant difference in energy consumption. So I wanted to take it a step further and see whether it was more or less. So I used a one-sided, which is t-test. The default is two-sided, that the means are equal, but I am going to test to see if the gas consumption is actually greater than the solar consumption mean. So the null hypothesis is that gas consumption is less than the solar consumption. And as you see here in the formula or the test parameters, we have alternative equal to greater. So that's our hypothesis. Our alternative hypothesis is that gas consumption is greater than solar. As we run the test, we get a p-value of 0.02, which confirms that gas consumption is significantly greater than solar, the mean is greater than the solar consumption. So as we visualize that using a box plot, have gas here on your left in blue, electric in the middle, and solar on the right in green, we see that the means are different across the board. They are different. The medians are different as well. And we do see that solar has an outlier, so that could be what is pulling that mean value down. So here's how you can apply real world scenarios to hypothesis testing.